Okay, good evening. Welcome to
FamilyMath175b Correction.
So we were talking about the square root of 2 yesterday, and I published a little blog about it, and one of my former students sent me a note saying we had made a mistake. And when I read what he wrote, I was like, oh, dang, he's totally right. We made a mistake. Okay, so in the second proof of the square root of 2 was irrational yesterday, we said we're going to assume it's rational. Square root of 2 equals a over b. And that meant we could square both sides and say that 2 times b squared was equal to a squared. Right?
Yep.
And I said, we walked through a little bit, and we said that perfect squares have an odd number of factors.
Yeah.
Right? Remember that? And I said, well, on this side, what we can do is we can take the factors and multiply either by 2 to the 0 or 2 to the 1. And I'll have all the factors of b here, b squared I mean, which is an odd number of factors, and all the factors of b squared here, which is an odd number of factors, but since I'm counting multiplying by 1 and multiplying by 2, I'm going to have an odd plus an odd, which is
An even.
an even. Give me the eraser, I just forgot to bring an eraser over. But this is a good example. I made a bad mistake. This argument is not correct. And I'm going to show you, and it's awesome that Andrew noticed this because we can learn from this mistake. Seems right? I got all the factors here, and then I multiply them all by 2. Yeah. But Andrew pointed out to me that you might have a factor here like 10 and 5 in your number. Yeah. And when you multiply the 5 by 2, you get a 10, and you already counted the 10. You see that? So you might have, these lists might have numbers that are the same in them.
Yeah.
And for example, just to make it even less abstract, if we look at 36, say b squared was 36. The factors of 36 are 1, 2, 3, 4, 6, 9, sorry the pen's going down, 12, 18, and 36. Right?
Yeah. Yep.
1, 2, 3, 4, 5, 6, 7, 8, 9. An odd number, just like we said.
Yeah.
So now I multiply them by 2 to the 0, so those stay the same, right? But now I multiply them by 2, and I get 2. Oh shoot, I already have that one. 4. Oh shoot, I already have it. 6. Oh shoot, I already have it. 8. Okay, that one's new at least.
Yeah. 12.
Oh darn, I already have it. 18. Oh, dang, I already have it. 24, I don't have.
18.
36, oh, I already have it. And then 72. So I have, the only ones that are new are 8, 24, and 72. Now luckily that's an odd number that are new, and still odd plus odd is even.
Yeah. But will that work always?
But will it work always? That is a great question. So we need to reformulate our argument here. Okay, and I have to go back. Remember I said it was well you probably don't remember. I said this was a modification of cut the knots argument. So cut the knots arguments are correct. And I have to sort of unmodify my modification. Which means what? If you modify something and then unmodify it, what are you doing?
It was nothing.
Right, you're going back to their argument. But the argument is now still fairly simple. This is going to be, b squared is going to be some set of primes. It's going to be 2 to some power 2a. So all the powers are going to be even, right, because they're squared.
Yeah.
Times 3 to the 2b, some even power of 3, times some even power of 5, 2c, etc. Right, and then when we find the number of factors of b squared, we add 1 to all the powers. 2a plus 1 times 2b plus 1 times 2c plus 1. So notice I'm multiplying an odd times an odd times an odd, which always will give me an odd. Now look what happens when I add in this extra power of 2 here. I get the power. What is 2 times 2a? What's the new power?
Well.
Sorry, 2 times 2 to the 2a.
It's 2 to the 2a plus 1.
Very good. So my new power is 2 to the 2a plus 1. Now I have to add 1 to this. So I get 2a plus 1, which is, what is 2a plus 1 plus 1?
Is 2a plus 2.
2a plus 2. What can you tell me about my product here?
This is going to be even.
Why?
Because odd times odd is even, and even times even is even.
Odd times odd is
Odd.
odd.
Then odd times even is even.
This is even. Why is 2a plus 2 even?
Well, this is even, 2a, and
Yeah.
then 2 is even.
Right, this is 2 times a plus 1. So I get an even number of factors. This side has an even number of factors. This side has
And
Odd.
an odd number of factors because it's a perfect square.
yeah.
Okay, so there's our correction. This is a precise argument. Andrew found, can you believe he noticed that when he was just thinking about it? That's pretty cool, right?
Yeah.
Yeah, and that's really critical in thinking. It's important for us to learn from that mistake. Is it okay to make mistakes in math?
Yeah,
What do you need to do though?
as long as you correct them.
Well, not just correct them.
Well,
What did we learn?
Learn from the mistakes.
We got to learn from our mistake. We had to make sure when we were counting those sets of factors that they were all different,
yeah.
but they weren't. Remember with the example of 36?
Yeah.
Uh-oh. But this is right. This is the right argument. Okay? All right. Thanks to Andrew for pointing that out. Andrew was one of my students back in Minnesota in 1997 and 1998. Long time ago. But it was nice of him to point that out.